Hey guys, we're going to take some notes for sticker 3. So let's do it. Okay, so we took notes on this today. And then here where it says classwork, where essentially we're doing this more for homework because this will be what the questions will look like. We also want to be prepared for A8, A9, and A10. Okay, so you don't have to do those, but it would be smart because I'm going to pluck at least one question from each of those sections as well. So you got to make sure you are comfortable with that. Okay, so it says determine whether set B is a subset of A. Okay, so if I had a circle A and I had a circle B, then the number 1, this would be twice. So A would be here, and B already got, there's no numbers in that category there. So 1 and 2 are in both, and 0, 3, and 4 are in none of the, are in A but not B. And there's no numbers that are just B, and there's no numbers that are neither A nor B. So how does this help us answer the question? The question is B a subset of A? Yes. B is a subset of A because the definition of subset is it all inside of there? Because 1 and 2 are all, the whole group, 1 and 2, are inside group A, 0, 1, 2, 3, and 4. Now, why is this important? Well, it's important because this is how we classify numbers as rational, irrational, integer, or whole number. Essentially, we could think of this as not these numbers, but we could think about this idea of a whole number and as an integer. So an example of a whole number is 1, 2, 3, 4, and 5, right? It keeps going. Example of an integer would be -1 or -3, -2, -1, 0, 1, 2, 3, 4, 5, yada, yada, yada. Notice how this is a subset of that. Whole numbers are a subset of integers. Whole numbers are a subset of integers. And that's what we discussed today in class. Okay, how would we do question number 7? It says determine whether set B is a subset. So we can highlight. Is that there? Yes. Is that there? Yes. Is that there? Yes. Is that there? Yes. 9 isn't. So no, B is not a subset of A because 9 is missing from set A. Okay? All right, how do I order sets of numbers least to greatest? Okay, so this we can, so step 1, turn them into decimals. Step 2, then order them least to greatest. Just abbreviating. Step 3, then don't forget to rewrite the numbers themselves that they asked you to order least to greatest. Okay, so step 1, we have to turn this into decimal. If I get a calculator, square root of 200. So let's get a calculator. Square root of 200. Hit the square root sign, 14,142. Notice that's an irrational number. It doesn't have a pattern, 14,142. So this is 14,142, and it keeps going, right? This is the number 14, and 14 thirds is 14 divided by 3, and that does have a pattern. 4.66666666. 4.66666666. So today in class we thought about what is rational. This is a rational number. And this is a rational number. Why? Because it's a number over a number, so that's a rational number. This is an irrational. Actually, I'd like to use a different color for that. All right, so rationals. I'm going to color green. And this is irrational because it keeps on going. Irrational because it keeps on going. Irrational. All right, but that doesn't stop us from, notice that's not one of our steps, classify it as rational or irrational. That'll just help us on IXL. But it will help us order these least to greatest. So we turn them to decimals, check 1. Now we can order these least to greatest. So that'd be 4.6 repeating, 14, and then 14.142, yada, yada, yada. So we did step 1, we did step 2. Now for step 3, we have to rewrite it based on the value. So this number, 4.6 repeating, is that same value, 14 thirds. Those are the same value, so that is least. 14 is still the same value that we started with, and now this number is square root of 200. So this is least to greatest. Now, we're going to look at question number 9, following the same steps. So 2 thirds in a calculator is 0.6 repeating. The square root of 9 over 16 is 3/4, so that's 0.75. And this. So if I think about these as rational or irrational, this is a number over a number. This doesn't look like a number, but it's a pattern. So that'd be 6 over 10. That's what that number is. And this number here is a regular number because the square root of 9 is 3 and the square root of 16 is 4. So that's why I wrote the number 0.75 because that's 3/4. All right, so how could I use, though, the calculator? The square root of 9/16. So 9 divided by 16, enter. And then when I take the square root, notice, see how I got that number 0.75. Okay, so 0.6, Ms. Cruzmark says that's the same number as 6 divided by 10. Yep, 0.6. All right, so in fact, although they don't look like it, all these numbers are rational because they don't keep going in an unknown pattern. So these are all rational. Let's order them. We turn them to decimals. Now let's order them least to greatest. So this would be smaller than this, right? This is 66 cents and this is just 60 cents. You see what I'm saying? And then 75 cents. So we've ordered these least to greatest. Now, you could do that 2 ways. You can do it with this symbol, or you can just do it with commas. Either way would be fine. And now, so for step 3, I have to rewrite it. So this is still this quantity, 0.6. This one is the number, 0.6 repeating is the number, 2 thirds. And this last number is the expression, the square root of 9 over 16. Now I've ordered these least to greatest. Cool. Okay, so that's it for notes, but we also want to practice A8, 9, and 10. Okay, so we'll go to IXL. So we notice our assignment here, it says you may also want to practice A8, 9, and 10 because I'll pull a question from there. Okay, so let's do a couple from A8. Rational or irrational? Oops, the link doesn't work because I'm not signed in. Okay, so I guess the link brought me to the right assignment, but it doesn't, I'm not signed in, so that's annoying. Let's go ahead and sign in. Oops, I meant to go to IXL. There we go. And if I go to my recommendations, you'll notice I put these recommendations there for you as well. So 8, 8, 9, and 10. Okay, so 2 is a regular old number, negative 10 is a regular number, and when I add 2 regular numbers, I still get a rational number. So these should all be rational. And rational, rational. So when I multiply 2 rationals, should still get rational. These should all be rational. So notice this is not a hard assignment. Ooh, this is irrational, because when I take the square root of 19, I get a big, ugly, unruly decimal that doesn't have a pattern. Okay, so when I add a big, unruly number to 9, I still have an unruly number. If I take this big, unruly number and add it to 9, it's still big and unruly. All right, but the number 9 is a rational number. So again, don't go on forever with this, but this is a big, ugly decimal. So when I multiply big, ugly decimals, I get big, ugly numbers. All right, so let's take a little bit to look at 9 and 10, classify, and then operations. These are similar to the ones we did in class. So when I add 2 rational, I get rational. Ooh, add an irrational to a rational, we get irrational. Add a rational to an irrational, we're getting irrational. Rational to an irrational, irrational. Irrational to irrational, still irrational. So wait, negative 5 and negative 9, those are totally rational, so we get rational. Those are both rational. Do we get how to do this? We don't have to do this forever. I'm not working toward a score. I'm just making sure that I can answer one of those questions. All right, number 10, what about when I add or subtract it? So pi minus c, if c is rational, so if c was pi, it wouldn't be rational. So if it's c minus 5 or minus negative 5, I'm still getting something that's irrational. 41 minus v, if we know that v is irrational, an irrational minus an irrational should still give me irrational. Uh-oh, what happened? Well, think about it a minute. I could have put square root of 41 minus square root of 41 and gotten 0. And that is, so look, they define it and they say, yeah, if v happened to be the number square root of 41, then we would have gotten 0. And the number 0 is rational. Okay, I got it. I understand what I did wrong. Go back. Okay, so an irrational plus a rational, I'm going to get irrational. Q is rational and 7 is rational, so I'm going to get rational. Base of a logarithm, that sounds irrational. X plus E, this sounds totally irrational, but what if it was negative E? I'm going to put this, see what happens. Okay, so it's an irrational. If I could add or subtract the exact same irrational, then I could have, what if Y? Well, it says Y is rational and negative, so it can't be pi or negative pi. So that should make it irrational. There you go. All right, so again, back in our notes, we took notes. We should get class notes from another person or from Miss Grusmark. You can take a picture of my notes and then submit this or give it to me next class. Don't forget to practice IXL 8, 9, and 10, not for a grade, but to be ready for sticker 3 next time. Take care.